Yeah, everything is clear.
Okay, so
Mara go pela before re ya gole o tlhalose gape intograph.
okay, a re ke tla e tlhalosa habedi ke re limit ya ka ke ela kwale. Okay, so guys, once again, I welcome you to my lesson for today. Obviously, we'll be looking at Physical Sciences Paper 1 of February, March 2018. So, ladies and gentlemen, at all times, you are advised to start each question on a new page. So, ladies and gentlemen, we are given a statement of which I'm going to quickly read and interpret as we move with the information given. So, a ball is thrown vertically downwards from the top of a building and bounces a few times as it hits the ground. So, guys, obviously, we can just make an assumption that we've got a flat and there we've got a ground. So, obviously, we've got a ball which is being thrown vertically downwards from the top of a building. So, assuming that this is the top of a building, we've got a ball which is being thrown vertically downwards from the top of a building, obviously, and bounces a few times as it hits the ground. So that means it's going to hit the ground, bounce, hit, bounce. We are just not sure of how many times it hits the ground. So I'll just indicate there that we've got the ground. So now, something that you need to notice is the fact that we've got this words, guys. An object can be thrown, an object can be released, an object can be dropped. So most importantly, ladies and gentlemen, in this case, if we've got an object which is being thrown, then it has a certain initial velocity, which is obviously greater than 0. But if an object is being released, its velocity initial is equals to 0. If they used the word dropped, it means its velocity is equals to 0. Very, very much important, ladies and gentlemen, to notice the difference between those words. So in this case, we've got a ball which is being thrown vertically downwards from the top of a building, which means we're going to have V initial, which is greater than 0. It could be 7, it could be 1, it could be any number. Obviously, it won't be 0. So, guys, that ball bounces a few times as it hits the ground. So, obviously, it hits the ground, it bounces, it hits the ground, it bounces, it hits the ground, it bounces. We'll find out how many times it bounces after hitting the ground. So, ladies and gentlemen, the velocity time graph below describes the motion of the ball from the time it is thrown up to a certain time t. So what I pick up from that statement is that we are given a velocity time graph. Very, very much important, ladies and gentlemen. A velocity time graph. Obviously, the vertical axis or the y-axis represents the velocity, which is in meters per second. The horizontal axis, guys, represents time, which is measured in seconds, which means there you've got 0. So that 0 is where the time is 0, where the velocity is 0. So anything above, we've got positive velocity. Anything below, we've got negative velocity. So time is always positive. Time is always positive. So ladies and gentlemen, what you need to know is that this is a velocity time graph. So I've got different type of graphs of which I've done a lesson. If you go to my website, under grade 12 physical sciences, you should find a complete lesson where I teach this chapter of vertical projectile motion in one dimension from the start all the way up to the end. I also include all the types of the graphs. So ladies and gentlemen, in this case, we're given the velocity time graph. So now they're saying this velocity time graph given below, it describes the motion of the ball from the time it is thrown up to a certain time, which is time t. So now let's have a look at the graph. So obviously take downwards as positive direction and the ground as zero reference. The graph is not drawn to scale. The effects of air friction are ignored. So ladies and gentlemen, what matters the most on that statement is for you to take downwards as the positive direction. So obviously that means for objects going downwards, we've got a positive velocity, which means for objects moving upwards, we've got a negative velocity. So what does it mean in terms of g? It obviously means we've got our positive g. Why positive g? Is because g is always exerting downwards. So since we're given an instruction to say take downwards as positive, it means our initial velocity is going to be a positive velocity. So obviously, as that ball strikes the ground, it strikes the ground and it bounces off the ground, which means we're going to have a negative velocity as it bounces and moves upwards, where it reaches its maximum height. So remember, where it reaches its maximum height, we've got V final, which is equals to 0. But before I go deep into explaining that, ladies and gentlemen, remember, we've got V initial, which is a positive value. We're going to find out from the graph if we'll be able to tell exactly how much is that V initial. As this object strikes the ground, we are going to have a V final, obviously, which is a positive V final. And again, as this object or the ball leaves the ground, we also have V initial, which is going to be a negative value. Why? Because this object is now moving in the opposite direction. Obviously, as it reaches its maximum height, negative 0, positive 0 is the same as 0. So, ladies and gentlemen, from there, it obviously strikes the ground again. As it strikes the ground, ladies and gentlemen, we are going to have a positive V. Very, very much important, ladies and gentlemen. Obviously, that means for every downwards movement, we've got a positive V. For every upward movement, we've got a negative V. So if this object strikes the ground and still bounces off the ground, it's obviously going to reach its maximum height or its maximum velocity, which is going to be V final, of which we obviously know it's going to be 0. Most important, ladies and gentlemen, this movement of it going up, we are going to have a negative V. And most importantly, guys, from that point, as it strikes the ground, we are still going to have a V final, which is a positive value. And again, as it leaves the ground, we are going to have V initial, which is a negative V. So this object can continue. Obviously, if it's a tennis ball, it's going to bounce, go up, bounce, go up until it now stops bouncing. But in this case, we are not told how many times it bounced, but we know it bounces up to a certain time t. So This graph is going to help us to determine how many times it has bounced. So, ladies and gentlemen, I'm not really sure if what I've explained so far it makes sense. Can someone try to unmute their mic and give me an indication if all that I've explained is clear?
Yeah, so far everything is clear.
Okay. I'm just not sure of something, but I'm just trying to think because I know I'm recording this lesson. I'm just not sure if it's recording in landscape or portrait, but otherwise, it's fine. If it's recording in, let me just try to confirm. Okay, let me just pin. If it's recording in landscape or portrait, it's fine. Mr. D, let me just quickly try to check something. Let me